Welcome back to another lecture of EE2080 Microprocessor Systems Design and Interfacing course. In this lecture, I would like to quickly go through the Logisim simulation of our 8-bit microcomputer. So this is two ways I'm going to help you out here. One is actually without the control unit. So this particular circuit that you see in the screen is without the design of any control unit. So it's a very raw 8-bit microcomputer where as a human we will be controlling the circuit, okay, controlling the flow. In the second part, we will have the automated one where we do have a control unit based on the design I presented to you already. So we will see how that works as well. So let's start. Okay, so in this case, just to introduce the architecture, I just followed exactly as we discussed. The blocks on the left hand side, you do have a program counter here, and then of course the control signal EP and CP, which are shown here. And I'm using displays to know what is happening on the bus. Okay, so we have the 8-bit bus here. Okay, and then we do have the memory address register with its corresponding LM bar, which is the control signal, which will connect the bus to the memory address register. And of course the bus is 8-bit, so we will not be using all the 8 bits, but rather the least significant 4 bits 0 to 3 or 0 to 3 is being used in this case to put it into the memory address register. Okay, and then we do have the RAM here, and it has a C bar enable signal, which is given as the address or enable part to the memory to the RAM memory. And of course I have loaded the RAM with some code. So this basically means 0B is the first location, 1C is the next location, E0 is the next location, and so on. So 0B, if you go back to the lecture slides, what does it mean actually is it is equivalent to LDA B. So that means whatever address is in the B should be loaded into the accumulator. 0 stands for LDA and B stands for the address location. So B here basically means this guy 05. So 0B, the instruction actually says you load the content of memory location B, which is actually this guy 05, okay, into the accumulator. And then 1C is the next instruction. So 1 stands for add and C stands for again the address location, which is this 12. So 1C basically means you add the content of the location C, which is actually 12. So first you have to load the content into register B, and then you add that with the content of accumulator, which was already this guy 5. So that result will be 17, something like that. And E0 is basically the out. E stands for out and 0 doesn't mean anything. So out is to display the output. And similarly we have another one 0D, again LDAD, that means load the content of address D to the accumulator. So address D has the content 13, so 13 will be loaded to the accumulator. And then 2E means you subtract the content of E from the content of accumulator. So basically the content of E is 3, that should be loaded to the register B, and then you subtract from whatever loaded in accumulator, which is 13. So 13 minus 3 is 10, which will be displayed here using the command E0. And then of course ideally you should put a halt here so that the progress of the thing stays there, but we have not implemented that yet in this code, so that's fine. So let's start. So let me just quickly reset the simulation. Okay, so you can go here and then reset the simulation. Everything will be reset, so even the memory will be cleared. So you need to load. So either you can double click like this. Okay, so you can edit the contents. So open up something like this, so you can manually edit it. So first time you may have to do it, so you manually edit it, and then you can save it as a file, MEM file. So I have already saved it, so I can load it. So you go to load, and then there is an MEM file here which will be loaded, and you see all the contents are back. Okay, so that's it. So everything is reset, and the thing is that the control signals are not proper. That is why the red warning has happened, because a lot of things are shorted here. For example, this is enabled, so this is already enabled and connected, and too many things so are connected. So what we need to ensure is all the signals are given corresponding value. That is the role of control unit, right? The moment the system is switched on, control unit should be proper during the fetch and the execute part. So let's make sure that everything is fine. So clear, if you want to make it clear to start with, so we'll do that last, but before, let's make all the other control signals the opposite of it should be, right? It should be all disabled to start. So CP, should be 0, no problem. EP should be 0, no problem. LM bar, if it is 0, it becomes high. That's why this is enabled. You can see a green, bright green here. That means this is enabled. So you make it 0. So this is disabled now. Right. So LM bar should be 1, so that the negative logic, this becomes basically disabled. Similarly, all bars should be 1. So this should be 1, this should be 1, this should be 1, this should be 1, this should be 0 because it's not bar. This doesn't matter because it's a sub and add operation. Default 0 is add. So you just keep it as it is. And then EU should be 0 because it's not negative logic. LB bar is negative logic, so that should be 1. LO bar is negative logic, that should be 1. So you see the red has disappeared, it becomes black and we are set. Now let's clear to start with. So I have a clear, I just trigger the clock, so it's cleared. So all registers are clear and you see RAM is not cleared. So that's a beauty. If I do reset simulation, everything gets cleared. Okay, so now let's move on. So now the first step, as you know, we need to connect the program counter to the memory address register. So for that to happen, we need to enable EP, we need to enable this connection as well, and then you trigger the clock. So let's do that. EP, so you go and enable the EP here, which is exactly this, and then of course the LM bar should be 0, so that is enabled. So you can see this is enabled, this is enabled. And now if I put the clock, this content which is 0 0 0 0 will go and sit here, but anyway it is all 0, so it doesn't matter at this stage, but let's do that. Okay, so one trigger of the clock, it is done. Now you ensure that, because you are the control unit now, so you have to ensure that the signals go back to their default state. So nothing is enabled now. Now next step in the fetch cycle, please go back to the lecture if you don't remember, or go back to the slide if you don't remember. The next part is basically the incrementation of the program counter. So we have to enable CP. So I'll put CP as 1 and then you trigger the clock. So basically this has become 1 now, you can see it over here. So I disable the CP because that part is done. Now next is basically you need to pass basically whatever is the address here is already pointing to the RAM, the address is already pointing, but we need to put that content into the instruction register. So for that to happen, you need to have this one enabled. So let's enable that. C bar, yeah, it's pointing to that. The dark shaded region shows that it's pointing to 0B. So 0B is or sort of now available in the bus here, but that should be actually loaded to this guy. So for that to happen, the LI bar should be going high. The output should be going high, right? So I just make it high. Okay, so that's perfect. So that means this connection is now enabled, but it will not come here until I trigger the clock. So clock triggered, and you can see 0B is already loaded here. So now we need to make sure we disable whatever we enabled. Sorry, C bar should be going low and LI bar should be going low. So going high, so that both are disabled. But the content is here. What is the next step? So the fetch part is done. I fetch the instruction from the RAM to the instruction register. So the next step is basically to execute that instruction. And remember, in the automated case, the control unit will take care of the most significant bit, that is what it is going here. So this is actually ideally going to the control unit, and the least significant bit is the address. So that address has to go back to the memory address register. So our role now as a control unit is to put this B, that's what the most significant is discarded because we are the control unit. Otherwise this should have gone to the control unit. But the least significant is basically the address of the data. So that should be going to the memory address register. So for that to happen, what is the thing to do? You have to enable this guy and to enable this guy so that this connection is established. So basically let's do that. So EI bar should be going low, so this is enabled, and LM bar should be going low, so this is enabled. So this connection is now established, but as I said, we need a clock to get this value B into this guy. So let's do that. So very good, the clock has done and it has come back. So let's actually, very important now, to disable all the signal. Control unit will do that automatically, but we are the control unit now. So remember to put it back. So this is disabled, and this also LI bar, you have to disable it. Okay, so that's also disabled. Sorry, not LI bar, it's EI bar, correct? So this is also disabled. So everything is disabled, and this guy has this, correct? And now next step is actually to this address that has to be loaded to the accumulator, right? So we need to actually now enable this so that that address, yeah, 0.05, which was actually the location B's value, that has to be put into accumulator. So for that, what we need to do, accumulator, where is accumulator? Yes, this guy. So this is to be, so this is connected, this is connected. So we will put that 1 clock. That's done. So let's go inside this. So there is an accumulator, and I didn't show you this before. So accumulator is here, register B is here, the add subtraction is here, and you can see over here the accumulator is already loaded with the content 05. So now let's go back. So that's done. Now let's make sure the control signals are put it back. So I disable the accumulator, I disable the CE bar. So this is again free for data transfer. So that's it. First instruction is all done. One cycle is one sort of instruction cycle is fully done, which included the fetch part and the execution part. So we achieved our role. What we did, we basically loaded the content in address B, which is 05, into the accumulator. So that is done. Okay, so this is how this automation works. Now just to give slightly more, so then next step again is the fetch part. So again first part of the fetch part is basically load the program counter into memory address register. So you have to enable EP. So let me enable EP, and at the same time enable LM bar. Okay, so this is also enabled, a clock. That's it. Memory address register became 1, and now the process repeats. So that's it. Okay, and let me actually complete this. Let's see the output. Okay, so I will just make sure so that you completely follow it again and again. So this is done. Now what is next? So EP has to be disabled, LM bar has to be disabled, and now we need to increment the program counter. So CP has to be 1 clock, CP is incremented. We can see it here. This is the binary, so this is 2. 0, 1, 2, right? So that is 2. Binary 2. Remember that. Okay, so this is done. Now what is the next step? This guy, whatever is the location address at 1, this is 1C, should be loaded in the instruction register. So for that to happen, you need to have CE, which is pointing to 1C, which is highlighted here, and at the same time LI bar should be going low, so that on the next clock cycle I have the 1C coming here. Ignore this because we are shorted, that's why this is showing some warning, but we don't mind. Okay, now put it back, LI bar to be 1, CE bar to be 1, so that is disconnected. And now what is again? We completed the fetch part. We fetched the instruction 1C into the instruction register. Now we need to do the execution part, and typically it is done by the control unit again, but here we are the control unit, so we have to. So C is the least significant bit that will have to be put into memory address register again. So for that to happen, EI should be enabled, that's enabled, and LM bar should be enabled, so that's enabled, and 1 clock I have the C coming here. So put it back. So EI bar I need to put it back to 1, LM bar I need to put it back to 1, but C is already there. Now again we need to make sure that the C is pointing. So when I put C bar here, it is pointing to 12, that has to be put in register B. So you have to actually enable register B. Okay, so that's done. Register B is done. So now I trigger the clock. That's done. Let's see inside this whether register B is yes, it is having 12. Okay, so that's done. Now we remember to set the signal back. So LB should be high, so that is disabled, and C bar should be high, so that is disabled. So again another execution done. So 0B done, 1C done. 2 instructions are executed already. And remember how many cycles we took? We had to click the clock 6 times. So click clock cycles. Out of that, first 3 will be the fetch, next 3 will be the execute. I hope you are following me. Okay, so now the last instruction, which is E0, which will display the output here. Display output of what? 12 plus 13. That's the meaning of these 2 instructions, right? So LDA B, add C, and out. That's it. That's what we are doing. So as usual, so the first step is program counter has to come to memory address register. So for that to happen, EP should be high, LM bar should be high. So these 2 are connected, and 1 clock cycle, you have the signal 2 here, and that is pointing to the address. And now let me go back and disable these 2. So that is disabled. Next is program counter has to be incremented. So let's ensure that. So this becomes 3, and then we need to point the 2 which is pointing to E0 has to be put in instruction register. So for that to happen, C bar, yes, that's highlighted. LA bar should come, yes. So this is connected now, and 1 clock cycle, you have that value here. So that's it. So let me just go back and disable the LI bar, CE bar, so that it's all disabled. Now what we need to do? We need to actually execute this. There's no data to be transferred now. So to execute E, we already know the output, which is actually, let me see. Oh, by the way, I didn't do the addition. Oh yeah, it is already available. Yes, the addition is already available here. So I shall put it output. So, but I didn't store, right? I think I missed it during the add cycle. I missed to put that in the accumulator. So let's do that now. Okay, ideally it should have been done earlier, but let's do that. Accumulator is still having 5, but we need to put this guy in. So what is to be done? What we have to do is, so accumulator basically has to be enabled here. So let's put that, sorry, load accumulator has to be made high. Okay, so I'm going to do that, and you have to enable the adder output to the bus. So EU has to be connected to the bus. So EU is connected, so bus is having, yeah, you have the result here. This has to be put it into accumulator. So I hope accumulator is updated now. Please remember this has to be done as part of the add cycle, but we missed it. So you can see accumulator is having 17. Okay, now come back. So disable the EU, which is this, and disable the LA bar. That's also disabled. Now we need to display the output from the accumulator. So enable the accumulator now, so that comes accumulator output gets connected to the bus. Okay, and then at the same time output register, we enable that so that the value comes to output register and gets displayed here. So now just a simple clock. Yes, we are done. That's it, done. So these 3 instructions actually did display the output of 12 plus 13. Of course, 12 plus 13 in hexadecimal is 17, which is actually displayed here. Okay, so that's it, done. I think everything is fine. Please experiment something like this to start with. I'm not going to share this code because it's your role to actually come up with the code. Okay, so this is the first part where everything is sort of done manually. So we took the effort to actually switch everything manually, which is not expected because we need to have a control unit to play with, right? So the control unit should automatically does all the things that we did so far. So I'm going to close this and introduce to you. Okay, so let's not save it and introduce you to the actual circuit which is expected from you as part of the experiment 1. The same circuit, the only difference is I have a very beautiful control unit which is coming up here. So let me just show you what is it. So the control unit, again the same concept that we discussed in the class. Let me quickly open the slide so that you have one to one. Okay, so this is the control unit we are trying to implement. So basically the instruction register, this is entire control unit if you want to see that way. So we do have one ROM, second ROM. So let's see that. So first ROM is exactly this one. So I already put the values in for you. And then the second ROM, which is this guy, is actually shown it over here. And this circuit is made as it is, which you can see over here. It's as made as it is. And then we do have a ring counter which is actually sitting nicely here. So if I see ring counter here, you can see it. So it just circulates a 1 throughout. It is not set properly. I will show you how to set it properly. So this is a ring counter which is this part. So it just puts 1 along these each of these lines. So basically one of them will be selected in a sequential fashion. So this is the first cycle, second cycle, third cycle. So these 3 forms the fetch part, and then 4th, 5th and 6th cycle, which is determined by the instruction based on this ROM, will be controlled by these 3. So that's the flow. And now let's go back and see. So let me go back to the main part. So important. So again, you reset the simulation. Everything is cleared. I need to load the content, the same content which we used in the previous experiment. So 0B, 1C, E0, 0D, 2E, E0, and so on. Okay. And so basically you can play with it. You can put whatever content you want, right? I just put the same content, that's all. And now one important thing is like I need to actually clear everything. So let me clear that part. Okay, so all registers are cleared, and let me see inside the ring counter whether it is set correctly. It is not, because all of them are 0 by clearing. So what I need to do is put a 1 inside here. So for that I'm using the set. So I go back here, the set is actually here. So I'll just put it one time, and now if you go back and see, it's not synchronous, it is asynchronous. So no clock is required, and you can already see this guy is 1. And if I go back to the control unit, this guy is selected. You can see it like this. So this basically is coming from here. So this guy is 0 is selected, and then of course that 0 corresponds to 5E3, which stands for basically the control signal, the first control signal. Go back and see what is it. It is nothing but EP and LM bar going high. So now let me go back. Okay, so I'm set, everything is set. So one thing I can do is manually trigger the clock one by one, so that you can see that cycle which is we did using selecting the control signal, but here ticking the clock signal will do it for you. So I'll just tick it. Okay, so first time this is already, so you can see it, this is already done, 5E3 is already issued. So this is already done, EP is high, this is high, so the program counter value is already coming to memory address register. So the next tick you can see CP is incremented, so still not done because the clock has to complete, so CP is incremented. Okay, now if I do next, what is going to happen is the memory address registers, this guy whatever is pointing to, which is 0, which is 0B, should be connected to instruction register. So let's see that. So you can see this is now connected, and I do it one more time, you can see 0B is coming here. So fetch cycle is done. Okay. So now one more time if I do, so what is going to the control signal now will get activated because it is 0, so all zeros here. So based on that, the next subsequent 3 cycles will be automatically, the signal will be issued. I just need to play on with the clock. So next thing we have to do is this guy, the 0, the B part should come to memory address register. Let's see whether it's happening. Yeah, it's happened. B is connected, and you already know this is pointed and this is also pointed. So, and now what you see is the 0.5 which will go to accumulator. Let me just see. Yeah, 0.5 is already there in the accumulator. Okay, so I go back to the main circuit again, keep on triggering the thing. So now you can see over here, this, now the execution part is also done. So you need to have the fetch cycle again. So you again EP this one, so that program counter content is stored to memory address register. So that's done. So 1 is arrived here. Now you increment the program counter to 2, that's also done. Now you see 1C is pointed, that will come here. Yeah, it is done. 1C is done. And then that based on the 1, the next subsequent cycles will be, or signals will be issued. So you don't have to worry. So the next step is C has to be loaded to the memory address register. Let's say, yeah, that's also done. Now the content is 12, that should go to the register B. Alright, so I hope it is done. Let's go back and see. Yeah, 12 is done. So that part is done. Now let's see, continue with the clock. Yeah, now again the content, this content has to be loaded to memory address register because the second instruction is also done. Now it's the out instruction. So you do it, yeah, it became 2. Now so E0 will go to instruction register, that is out. Yes, the output is come. So basically you executed this and this. So add the content of, load the content of B to accumulator, add the content of C to the accumulator, and display the result. So basically 12 plus 5 is 17. I think I made a mistake in just before. It's 12 plus 5, not 12 plus 13, right? Okay. So that's it. You can continue to play with and see the result of the next 3 instructions, which is 0D, load the content of D to accumulator, subtract the content of E from the accumulator, and display. So basically 13 minus 3 will be 10. Okay, so you can see that. So I didn't put the halt again here. You can do that, so that you put a halt here, the execution will be stopped. Otherwise what is going to happen is, as the program counter keeps on incrementing, this guy will go, and so halt, basically all you need to do is disable the program counting, override this guy and disable the entire stepping further, right? So that's it. Okay, so I hope this is very clear to you, and there is a way to, instead of clicking it, there is a way to actually continuously run it. So let me show you that as well. So again I will disable the clock, clear the circuit. Okay, so I'll this, and then of course set it. So ensure that this is, go back here, this is 1. Okay, so that's ensured. So that's it, you are ready to start the circuit. Oh, in fact the clear didn't work, so maybe let me just I think I didn't use the clear here, that's why. So maybe let's do the reset. Okay, and then you load the content back. Okay, so that is done. Now setting, I think it's already done. Is it done? No, it's not done. So you have to do the setting part. Okay, so now yeah, this is done. Go back again and check, ensure. Yeah, this is done. Now is the beautiful part. Now what you need to do all is simulate. So there is a tick frequency. So let's put it as 0.5 hertz, because otherwise it's very difficult for you to see it. And then ticks enabled. Tick 1 means just like we did before, only once it will tick. Ticks enabled means it just goes. So it will be very fast. Just see the flow. Okay. So first incrementing this, then this guy is put to here. Yes, and the B will come here. Done. And then this guy 0.5 will go to the accumulator. Okay, we will wait for the next CP because that is already done. Yeah, now this is loaded. CP is incremented. This is 1C going to here. Yes, done. So C will go here. Yes, and this 12 will go into the register B. Done, very good. And then what is going to happen is again this guy will go here. So this becomes 2. Yes, and then incremented. So this becomes 3. And then this guy E0 will come here. Yes, done. So E will go and check the instruction. So you'll wait here. 17. Very good. So that is done. Now again it goes back. So yes, this is 3 here. Yes, and then is incremented to 4. Yes, done. This 3 is this instruction which will come here. Yeah, 0 will go to the control unit, D will go here. Yes, done. So 13 is the content which should be loaded in the accumulator. So that's done. Now again this connection will come. Yes, that is done. So that is means it will become 4. Yes, 4 is done. Incrementing happens. So 5. Now this fourth content which is 2E should come here. Yes, done. So 2 will go here, E will go here, it comes here. Yes, and the ETH location is 3 which will go to the register B. And again this will come. Yes, so this will become 5. Yes, this increment 6. Yes, so fifth location is this E0, that is the output. So wait for the output. Let's see the output. So E0 will come here, but then later on it will come here. That's it, done. So we are done, and this is what is expected of you in the lab as well. And I would encourage you to even change this display with a 7-segment display which is available here. So if you see the basically the output option, input output option, you have a beautiful keyboard, you have a beautiful 7-segment display, so many options. So why don't you try those out instead of this sort of boring display? Okay. So do all that, experiment with it, you change the control unit to your circuit, you add functionality if you want, all those will carry extra credits, and we are looking forward to all those experiments from you. Okay. So this sort of completes the lectures on the 8-bit microcomputer, and now we are looking forward to the practice part. So I expect each one of you to submit your own 8-bit microcomputer to us. Okay. So we will move on to the major part of this course. We are slowly going to introduce the ARM processors and the microprocessor architecture and all those things in the subsequent lectures. So looking forward to that. Thank you for joining.